everyone, and thank you for joining us today in this technical demonstration section. My name is Victor, and together with Henry, we will be walking through some of the key features and functionalities of ArcGIS Pro.
ArcGIS Pro 3.1 is our latest desktop GIS application designed to be the next generation of ArcMap. In the following, we would like to demonstrate how to make use of ArcGIS Pro to solve real-world spatial analytics problems in both 2D and 3D.
Let's jump right into our ArcGIS Pro interface. We begin our story in Kowloon East of Hong Kong. As city planners of Kowloon East, we need to review the coverage of existing government services in the area. The Kowloon East region is divided into several parts according to the tertiary planning units. And we plot the location of existing government offices on the map. To understand the extent of area that these offices are serving, we can use the surface area tool in ArcGIS Pro. By using Hong Kong's 3D pedestrian network and setting the cutoff parameter at 500, 1,000, and 1,500 meters respectively, the surface area with the corresponding walking distance then can be generated. It appears that the area near the edge are not really within the 1,500 meter walking zone from a government office. Before we judge, let's also overlay the map with the population projection data from year 2019 to 2025. All data are already available in the government's latest open data platform, the CSDI portal. Notice that the western and southeastern sections are having the highest population growth, which are indicated in dark green. Therefore, when we combine both the surface area and population projection, it is obvious that the western and southeastern section are having the highest demand for the new office. Since the western area, which is Kai Tak, is still undergoing a series of development by the government right now, that means that the bottom right area, that is Yau Tong, will be where we are most concerned about. However, Yau Tong is still a rather big area. How do we further narrow down our site selection for the new building?
We can perform a suitability analysis to solve this. What we do is to consider a few criteria and aggregate them to find out the best location. Here we first consider the sites that can be developed. Areas in red are private and developed sites, while those in orange are available for further development. And we take the existing building and structure into account. The red is where we have existing building, and the orange is the opposite. Also, the gradient of the area. As a location on flatland is surely more pedestrian-friendly than those on steep slope. So here, the red locations are steeper, meaning that they are less preferred. And availability of public transport nearby. Again, areas without transport access are shown in red. Lastly, we don't want to build anything on road full of traffic, which is indicated by the red line. Now we have all our criteria and ready to move on to the suitability modeler to summarize them. We first input the 5 criteria into the modeler. Then we define how important each factor is by changing their weight. Here we believe that the site factor is more important than the other, so we set it to be 3. And here we go. We have successfully identified a good piece of land for our new government office. The color on the map indicates the suitability of the area. The greener it appears, the more suitable it is. Let's take a closer look to the selected area right in the middle of Yau Tong. Now, let's assume we will build a new government office here in the green site and create a surface area to understand the extent of area the office will be serving. With the new government office, the Kowloon East population should be much better covered than before.
As you can see, there are quite a number of steps for selecting the site. But don't worry, ArcGIS Pro comes with the Model Builder, a powerful interface to state the steps of your complex workflows without any coding. So next time when you need to perform a similar analysis with just one click, and the model will run for you automatically.
Sounds great. Now we have the perfect location for the office. I believe engineers should be concerned about the geology underneath before building anything on top.
With the power of ArcGIS Pro, the underground world will not be a mystery. Let me show you how we can display the geological features through a voxel layer. First, ground investigations are typically done before any construction to study the geological conditions of the site. We obtained the data collected from these studies, which are in a file format called ArcGIS. This is how the original data look like in its text file. However, with ArcGIS, we can easily import the location information of these data and plot in our 3D map, where each point is a record of the weathering grade there, or in other words, how broken down the rocks are. These individual points are of course not sufficient to show the whole picture. Fortunately, we have the empirical Bayesian kriging 3D tool in ArcGIS Pro. It combines statistical modeling and interpolation to create high-quality 3D surfaces from sparse data. Here in the tool, we can set the input features to be our data points and set the value to be our weathering grade, which brings us to 2D layers across the depth of the data points. While each 2D layer does represent the geology along a particular depth, it is still rather difficult for us to visually interpret them. That's why we can convert these layers to a 3D voxel layer that resembles a geological model just below the surface of our site. Whether you are looking at the general distribution of rock types or even weathering grade at only a specific position, ArcGIS Pro and voxels can reveal what is underground and facilitate any engineering designs and constructions that follow.
Once we have got all this visualization on ArcGIS Pro, we can easily upload the results to the web application, allowing us to display our voxel on any common web browser. Any stakeholder can access the results even without having their ArcGIS Pro on their workstation. In this application, let's do some slicing. This basically creates a cross-sectional layer. By dragging the slider back and forth, the position of the slide can be adjusted, and we can then look at the internal geological distribution at any location. And it's just as easy to do some filtering. For engineers, they may want to see the distribution of one specific weathering grade layer. By using the filtering function, we can easily single out targeted layer. Multi-dimensional slicing enables us to further narrow down our focus to a particular location. With the voxel visualization combined with the web app, we extend the target audience not only to the professional, but also all stakeholders or even the public.
And with these, we can accurately design the new government office while ensuring its safety and stability. Now it is time to design our new building. ArcGIS Pro enables us to create 3D models using the default 3D editing tools. This capability is perfect for drawing a sketch and have a preliminary design of your architecture. Let's give it a try. First, we place the footprints of our future building into ArcGIS Pro, which consists of a twin tower and a connection in between. This will be the base of our building. And we can adjust the height by dragging the pointer upward, which essentially creates an extrusion from the footprint. Here, by selecting the tower on the left and dragging the pointer upward, we have successfully extruded from the footprint. And we will do the same on the second block of our building, but instead of dragging it manually, we can input the height directly by typing. After having made the twin tower, we can continue to elevate the middle section upward. The move to function in ArcGIS Pro allows us to type in the altitude where we would like to put our middle piece at. Let's call this place the Sky Hall, since we envision it to be some kind of conference area that hangs mid-air in between the two towers. And how about adding more fine details to our model? We can push the wall on the left-hand side inward to give it a cosmetic upgrade to the tower exterior. Now as we push the wall inward, does it look more three-dimensional? Anyway, the takeaway is that with as much creativity as you have, there are sufficient drawing tools available for you to realize your design. The 3D editing tool supports adding multi-patch texture that allows us to apply images to the facade and enhance its appearance. We click on the surface that we're going to apply it on and load the texture and choose the image file that shows the exterior design. And we have successfully sticked the image to the building surface. This is how it looks like with all the windows and walls being sticked on it. And with a few easy steps, we've already created a brief sketch of our future building. Having the model in ArcGIS Pro means that we can also perform 3D analysis together with the virtual surroundings nearby that actually exist in reality. Coming up next, let's do some 3D analysis. We can assess the scenery from any perspective by using the viewshed tool, which calculates the visible area from one or more viewpoints. The panel on the right is where the parameters such as the horizontal or vertical angles of the observer and the distance that he can see are being inputted. Here we will change some of the parameters of our viewshed. And that is how we can get our viewshed result. From an observer, the green area indicates where he can see, and the purple area is where his sight is being blocked. This tool takes into account of terrain, elevation, and other obstructions, like buildings. We can even move on the map to see the results interactively. And with that, architects and planners involved can visualize their designs and understand how they fit in the actual geospatial context.
Based on the preliminary design, colleagues from the building information modeling teams can further work on create detailed beam data. ArcGIS Pro allows us to view the beam in their actual spatial context and landscape. Beam files in Autodesk Revit, Civil 3D, as well as IFC format are now can be directly read. We can create an overview from the exterior shell defined in what we call the building scene layer. With ArcGIS Pro, we can easily navigate through the model from every possible angle. To simulate the view from inside the model, we can set the viewpoint and see what the future scenery will look like through the windows. Building are complex. Building scene layer organize the beam into different work disciplines, such as architectural, structural, mechanical, and electrical. It is essential to be able to filter individual elements by discipline or their characteristics. And to make it possible to see inside building, we can make use of the slicing tools. The slicing shape can be either a plane or a volumetric shape. The plane acts like a wall that can be positioned in the view, rotate or expand. And we can use multiple slicing, vertical or horizontal, in a single screen to achieve a more advanced display. So now, with just a few easy clicks, you can easily view the internal structure of that model.
ArcGIS Pro can support site selection, design, planning, and construction processes through its comprehensive capabilities in geospatial analytics, spatial data management, and robust visualization. We encourage you to explore the possibility of using ArcGIS Pro for your future projects in multiple fields. Now that we have covered the key workflow to finding a new site, what if we want to optimize a network of existing facilities to better serve the public or customer demands? Let's move on to another robust tool in ArcGIS Pro, that is location-allocation.
Let's jump back to our ArcGIS Pro interface. As government officer, it has always been difficult to place public facility in the best location to achieve high cost effectiveness. In these examples, let's see how we can allocate vaccination center in optimal locations. First of all, we should find out where the demand is. Vaccination centers are supposed to serve everyone in the society. Again, we can make use of the tertiary planning unit. This time, we use the subunit that is divided down to block level. For this location allocation analysis to run, it requires point data, so we generate a centroid for each subunit. It more or less represents the population distribution in Hong Kong. Next, we need to figure out the facility to become the vaccination center. Logically, we can make use of the existing government clinic to serve this purpose. According to the government open data from CSDI portal, there are in total 73 government clinics. Then we need a set of network data. Assuming that most citizens prefer going to the vaccination center on foot nearby, we use the 3D pedestrian network published by the NANS department and set it as our network data source. Further down in the toolbox, there are several network analysis types that we can choose from based on different objectives. For these examples, we choose the location allocation. Location allocation helps us to find the best location for public facility or business to serve a set of demand location. So now, a location allocation layer is created. Click the import facility. we can assign the 73 clinic as candidate. And click the import demand point. We can add the TPU centroid as the demand. In total, there are 2,300 demand points. Normally, we don't expect a long walking distance to the vaccination center, so we set the walking time cutoff as 15 minutes. And we choose the tool type as maximize coverage and minimize facility, which is exactly our intention. By running the tools, the allocation algorithm behind the scene will instantly help us to choose the best located clinic to cover the most demand. As on the map, the analysis results show how the demand points are assigned to nearby clinic. As we find out, 64 out of the 73 clinics have been chosen, covering around 73% of all the demand points.
Great, but there's still room to further increase the coverage. We should consider other government facilities to serve as vaccination center. How about public libraries?
Sure, we can again import the public library location data from the government CSDI portal into ArcGIS Pro. There are nearly 200 public libraries. Running the tools again by setting the 64 clinic as required facility type and the library as the additional candidate facility. As shown, 71 libraries have been chosen, and the coverage of the demand point increased from 73% to 85%.
What if we can't afford to add that many libraries? Manpower and facility expenditures are also practical constraints.
Yes, location allocation can simulate different scenarios. For example, if we can only assign an additional 40 libraries instead of 71 to be the vaccination center, let's see the coverage change. This time, we set the number of facilities as 104. It comes from the 64 clinic that was chosen from the previous analysis, plus an additional 40 libraries. The tools will then pick the 40 best located library to be our vaccination center. By reducing the number of required library from 71 to 40, the coverage have only decreased from 85% to 83%, which is quite similar. In this situation, perhaps it is more sensible to add only 40 library to strike a balance between cost and benefit.
Perfect. With this powerful location allocation tool, we can now make data-driven decisions to optimize the placement of your facilities and business to better cater for your customers and community. In another example to showcase the analytical capabilities of ArcGIS, we would like to introduce you to ArcGIS Knowledge, a brand new product that integrates graph and spatial analytics, also running on ArcGIS Pro. Let's take a look at how I work with Henry, a food safety regulator using ArcGIS Knowledge to trace the source of a foodborne illness outbreak. Our story starts right in Hong Kong, where several people got sick with cyclosporiasis.
Again, please.
Cyclosporiasis. That's an illness that would get you diarrhea. It is commonly associated with contaminated leafy green vegetables. We need to figure out the cause of this outbreak.
As a food safety regulator, I interviewed the people who got sick, and they list what restaurant they ate at and what menu item they ate. Then I plot the restaurant on the map and run the analysis to link the restaurant to the people. They didn't all eat at one single place. If we continue to look further back in the food supply chain, we learned that the restaurant brought ingredients from many different vendors, and the vendor bought raw food from different suppliers. But to figure out what those cases are in common, we need to see more, something beyond the map.
And this is when we can use knowledge graph to solve the problem. Let's take a look at a small slice of the data in the knowledge graph by expanding just one person's supply chain. And her name is Charlotte. Charlotte ate at 3 restaurants, which bought ingredients from 11 vendors, who bought raw food from another 74 suppliers. To make this chart more understandable, we can choose a left to right layout. When we expand the analysis from Charlotte to include everybody who got sick. It gets really complicated. But all of this data are in fact the connections between the people and the locations through the ingredients.
We already know that we are looking for a leafy green vegetable because of the nature of the illness. But how can we find out the common denominators among all those individual supply chains?
We can perform a graph query, which describes the path from the people through the ingredients all the way out to the suppliers. When we add these results to a new view, now it is quite clear. The contaminated food was most likely the Roman letters sold by two different vendors, vendor 13 and 15, indicated by the purple icons. And they sourced the letters from supplier 1, which is the black icon in the middle. In other words, supplier 1 was most likely the contamination source. And this was a quick supply chain traceback investigation to illustrate how knowledge graph can extend what you can do with GIS.
But what if the data is missing a relationship, a key connection that tells more of the story? This is why knowledge graph work hand in hand with spatial and visualization and analysis tools. Through our outline analysis, we discovered two people, Adam and Joe, did not eat at the same place as everybody else, but yet they got sick. They ate at the sandwich shop, but the sandwich shop got their Roman letters from different vendor and different supplier.
If they have separate supply chains, these cases should be disconnected from the others. So what happened?
With ArcGIS knowledge, we are not limited to the knowledge graph itself to understand our data. We can switch right back to our map. And when we take the geospatial perspective into account, and we ask where the sandwich shop is and what else nearby, we can see that the sandwich shop shares the storefront with the house of kebab, which is linked to supplier 1. So there is a good chance that they have got some cost contamination due to their geographic proximity. Based on this result, we further interviewed the two restaurants and find that sandwich shop borrowed some Roman letters from their neighbor as they ran out of ingredients unexpectedly one day. That may explain how Adam and Jill got sick.
With ArcGIS knowledge, we ensure that our lunch here today will not contain letters from that supplier 1. But more importantly, next time when you use mapping and spatial analysis tools to discover how things are related through time and space, you can also combine this with other non-spatial relationships in your data to solve new kinds of problems. Thank you, and let me pass over to the next section of our demonstration.
Thank you very much.
Thank you, Henry and Victor. Hello, everyone. I'm Gigi, and here we have Samuel with us. ArcGIS provides powerful web-based GIS platform with ArcGIS Online, the SaaS solution, and ArcGIS Enterprise, the on-premises solution. Now, let's explore the power of ArcGIS Online to facilitate the Clean Up Hong Kong campaign. Now, we have a hygiene black spot layer overlaid on the Hong Kong base map. With the map viewer, we can visualize the data with different style and perform further data analysis with smart mapping. We can use the time slider functions to visualize the temporal distribution of the black spot throughout the year of 2022. And we can also define the unique symbol by major problem and adjust the style by color scheme. How can we find the predominant class of the black spots?
We can now leverage the data aggregation functions on the ArcGIS map viewer. So by using clustering function, we can now understand the predominant class of the black spots among the district. And from here, we can see that there's a big cluster in the central western district. And for the red color, it illustrates that the hygiene condition of the reeling is the major problem of the hygiene black spots. This clustering function, we can change the size according to the change of the map extent. Moreover, if we want to understand the proportion of the black spot by each black spot type, we can also change the display in a donut chart. Apart from the cluster point visualization, we also want to understand the concentration of hygiene black spots by the spatial distribution. For example, the tertiary planning unit. So how can we do this?
We can figure it out with ready-to-use spatial analytic tool. Let's run the tool Summarize Within with the small TPU layer. After running the tool, we can see that the Shakthong 2 is the region with higher number of black spots. We can also create inspiring charts with analytical results. Let's click on the charting button to the left and create a stock chart with the results. The distribution of black spots of each region is now presented in a single chart.
That's great. Now we can use this web map to create our monitoring platform with our ArcGIS Experience Builder. So in the past, creating a standard application is complicated and need much time. But now we can leverage ArcGIS Experience Builder with a configurable web application to create dashboard, map-centric application, or the web pages with all the templates.
So now let's select the billboard template, and we can create the application with a list of ready-to-use widgets. It is very easy to add your preferred widgets in the applications. By simply drag and drop, you can add the feature info box widget to the interface without any programming skills. Another highlight of the Experience Builder is to create a mobile responsive applications for the laptop, tablet, and mobile. The size can be automatically adjusted to fit the screen size. After completing the configuration, the web app is now ready to use.
And here we go, we have a Clean Up Hong Kong map, which is a monitoring platform for our hygiene officer to oversee the black spot problem over Hong Kong. In this case, our officer would like to perform the inspection on the rear lane in the Central Western District, as we have analyzed. So with a few sample steps of multi-factor filtering, now our officer could identify the black spots which are pending for inspection, and we could now be ready to assign our inspector to perform the inspection on site. But in the last step, we need to plan the route for the inspection. So any suggestion?
So we can use the direction widget here. With the filtering result of the black spots, we can set up the stops and generate the shortest route by walking. We can also obtain the estimated time and distance of the inspection route. Now, the inspector can do their inspection work with the planned route.
So now all the information is ready, and our inspector could now go to the site to perform inspection with our latest ArcGIS field maps, which is a map-centric mobile application that our users could access to the same web map to perform the inspection. So in this case, our inspector will review the condition of the black spot type with a predefined list of options, which will save time from the manual typing and also typos. In addition to textual information, we can also upload photos and also other attachments to illustrate our reports.
What's more, the updated records can be immediately shown on the management dashboard, and the manager can do some filtering on the black spot type on the map by clicking on the map-sensitive charts.
Such a comprehensive workflow with ArcGIS Online. However, only the hygiene officer is not enough to oversee all the black spot and potential hygiene problems in Hong Kong. And now we need all the public participation for us to crowdsource the information of potential hygiene problems. And so here we come with the ArcGIS Survey 123, which is a form-centric mobile application for our users to report the problem from anywhere and anytime with the portable devices or on the website.
With this ArcGIS Survey 123, the officers can configure the smartphone with a list of question types. Adding the location elements in the form is also one of the spotlights of Survey 123. The map can connect with built-in mobile GPS receiver and produce textual location information in the survey.
Another highlight of ArcGIS Survey 123 is the high flexibility of the survey logic. In here, our officer can set up different types of questions according to each major problem. For example, we could report on a mosquito problem, and we can have a multiple choice question or the range question to report on the severity. Or we could upload the audio file to illustrate our findings on the noise problem. But now here, we would like to report on the illegal parking of bicycle. So let's input the number of the bicycle we've observed, and also we'll upload the photos of the illegal parking. And with these few simple steps, all the information is ready on the smartphone, and we can submit the form back to the officer, and the officer can observe the result immediately on the web platform.
So now, let's do a quick research on how we reach the hygiene standard of our living community. May you please pick up your smartphone and scan the QR code on the two sides of the screen, or the QR code just back of the seats, and let's see how we rate our community. So can we guess how much records can we have here?
Yeah, they have some 30 seconds to fill in the form, and let's have your review on the district.
And now we see some inputs from the
Yeah, the number is
Yaoqiong
rising.
district and also the Kuntong district. And it seems that the Wanchai district is one of the most people
Well, I
submitting
think
the
the
records.
Kuntong is catching up. And see, is there any further inputs now?
Yeah, and now we have 72 records submitting the records, and it seems like most of us think our district is more dirty.
Yeah.
Right.
Yeah,
Because
because
maybe
most of
we
district
did
is
there.
dirty, and yeah, at this moment,
I think, yeah, Yaoqiong district is rating high now. I mean,
Yeah.
like, Yaoqiong district is catching up with Kuntong, there, you know, side by side, and also the Samshepo district. And seems like the Samshepo district is rated to be the most dirtiest district, and the Southern district is the most cleanest district. So we are now in the most clean district in Hong Kong. That's good.
anyway, it's just a demonstration to show how we do the outsourcing. In this case, our officer could present more resources and arrange more resources to oversee the problem of hygiene in the Samshepo district. So with the use case of Clean Up Hong Kong, we hope you can experience the all-round capability of the web GIS. And beyond of this, let us appreciate the real-time analytics on the web GIS also.
We have talked about real-time GIS for long, and it's time for us to look at the integration of IoT sensors with GIS. Smart Site Safety System is a common topic among the construction industry, and ArcGIS Geo-Event Server and ArcGIS Velocity provides the capability to integrate real-time data into your GIS and help to maintain the 4S. In the back-end model builder, you can connect the feeds from the sensors by configuration. Then, you can start to build your own building management dashboard. Here is a map showing all the properties under the management team. And there, you can see a yellow point indicates the building that installed the IoT sensors. The related parameters can be shown in dashboard also.
So now, let's have a live demonstration to see how the sensor integrates with the building management platform. And here we have the blue board that installed the two sensors. The first one is a temperature and humidity sensor. So with the sensor, by putting the hot water nearby the temperature and humidity sensor, let's observe what changes on the dashboard. So with this sensor, we can see that the temperature will immediately surge from 26 to 34 degrees, and with the humidity value changed. And let's see another example of the water leakage sensor, which will help us to detect water leakage in the building apartment. And here we simulate the situation by putting water sensor in the water bottle. And let's see what happened. And now, as you can see that, in this demonstration, we can detect the water leakage at the first floor of the server room. So with this integration, we can see that how fast we can present the real-time situation in the building. Apart from the 2D information, we can also navigate to the 3D environment to observe which part and what facilities is affected by the water leakage. And here is a 3D map that indicates the parts that is impacted by the water leakage. So with this example, we hope that you can experience the powerful integration of the real-time analytics and also the building management platform on the GIS.
Apart from the smart site safety system, ArcGIS Velocity can be used to facilitate the logistics. Here we have a logistics center on Lantau Island, where the manager is going to monitor the cargo delivery and collection status. In this dashboard, the yellow zone indicates the 30 minutes driving time from the logistics center. When the truck enters the 30 minutes driving zone, the status of the truck will change, notifying the manager to get ready to accommodate the truck. With the real-time dashboard, manager can have a clearer picture on the logistics status and allocate resources in a more efficient way for cargo loading.
So with this showcase, we appreciate the integration of the ArcGIS on real-time analytics for different operations. So now let's appreciate the reality capture capabilities with the side scan of ArcGIS.
Application of drone mapping is becoming a hot topic in recent years. SiteScan for ArcGIS provides a fast and high-quality solution to generate high-quality 3D imagery products such as mesh model and overall mosaic photos in a few steps. In the following, we're going to demonstrate the use of SiteScan of drone mapping in Tongchong. SiteScan is used to collect drone photos and generate mapping products. It helps initiating the 3D flight path planning modules and define the area of interest for the flight. SiteScan can auto-calculate the number of photo-taking points to ensure an 80% of overlapping rate for accurate mesh model generation.
That's great. After we collect the drone image photo in Tongchong, we can now upload the photo to SiteScan Manager to process the drone mapping product. And we can also import the ground control point to improve the accuracy of the result as well. So this process is much faster than the traditional methods, thanks to the elastic cloud setting of SiteScan that allow us to generate the drone mapping product in 2 hours. So for the 2D drone mapping product, our users could immediately obtain the overall mosaic and also the digital terrain model on the SiteScan Manager. For the overall mosaic, sometimes we would like to compare the images collected in 2 different times, and this can be also done on the SiteScan Manager. So now we put 2 images into the timeline functions, and we could do the comparison of the visualization by swiping. So when we perform swiping, the differences between the 2 images can be easily observed and also identified. After from the 2D images, we can also observe 3D data, such as the point cloud model here. As we can define the area of interest to display the height profile of the point cloud model. And we also export the result as a CSV or the point cloud model in an LAS format.
After that, a 3D mesh model can be generated automatically from the SiteScan with the photos collected from the drone. It can be viewed from different angles and have a whole picture of the digital twins of the scanned location. The mesh model and other auto-rectified products can be exported and downloaded for analysis and visualization purpose in ArcGIS Pro, ArcGIS Experience Builder, or other visualization platform. By sharing the drone mapping products in our web GIS platform, they can be easily shared to your colleagues or even public through the internet for easy data dissemination. In the map viewer of ArcGIS Online, you can view the color-coded point cloud layer and choose the symbology according to your needs. For example, the field class and elevation of the point cloud.
So apart from drone mapping, AI is another hot topic. And with GIS, we could introduce the infusion with the AI, and which we call the Geo AI, which will help the machine learning for data extraction and image detection, object detection more easier. So in this example, the unstructured data with the location, address, and date can be extracted and transformed as structured data automatically. If using the Jupyter Notebook in ArcGIS Pro and ArcGIS API for Python, we can do the machine learning, which eliminates the need to copy the information to external database by manual. Also here, we use the BERT model with the TensorFlow that's used to train the dataset for the named entity recognition, which helps us to recognize the address and also the date from the unstructured text. And we could also code the result on the map too. So here we'll run the model inference, and we'll process the unstructured text and plot the data as a point layer on the map. So in this example, as you can see that we have used thousands of points to train the model, and here we recognize 12 points. And all the extracted information could now be stored as an attributable in a structured text format. So in this example, as you can see that the integration of Jupyter Notebook and also machine learning in ArcGIS could improve the productivity by streamlining data processing and also the extraction of data.
Let us zoom to the Hill fire incident in Tongchong with the result generated from Geo AI and turn on the image layer downloaded from Planet Imagery. We have 2 images now. One is showing the area before the Hill fire, and one is showing after the Hill fire. To compare the difference between the 2 images, we can select the swipe function. Can you see the difference in the middle of the images? And we can also perform the change detection on the imagery. Let us click Imagery and then Change Detection. On the pop-up screen to the right, we can select the respective imagery for analysis. And also, as we're detecting the vegetation cover changes in the imagery, we can choose NDVI and the respective banding for the analysis. After you run the toolbox, a polygon is generated, indicating the area that have changes.
In general, the image analysis can be applied for large-scale monitoring. While using side scan, we can perform the precise location investigation. We can also overlay the result of side scan, such as the ortho mosaic, to the result on ArcGIS Pro, so that we can observe and match if the ortho mosaic match with the site environment, and if investigation is needed to perform on the site. So apart from that, we can also import a mesh model on the ArcGIS Pro and compare with the 2D map and ortho mosaic side by side for the further comparison.
3D GIS can be empowered by gaming engine and produce a more realistic experience to users. Using the game engine to show the 3D models can utilize the ray tracing capability to model the light transport in the application. Let's see how we can use ArcGIS Maps SDK in game engine to render a city model.
With ArcGIS Map SDK for game engine, it is compatible with both Unreal and Unity. And in this showcase, we'll use the Unreal Engine. So by making use of the latest city mesh model of Hong Kong from Lens Department, the following demonstration will bring you an immersive experience of exploring the Hong Kong city virtually.
With ArcGIS Maps SDK for game engine, you can create an immersive 3D experience. You can also make use of the 3D model and build an immersive city or gaming engine for your audience. Simulation of real-world experience is presented in the scene. And realistic simulations can also be presented by showing the change in daytime to dawn to night. You can also customize your city with 3D objects, and the movable 3D models can be placed in your city to simulate a more realistic 3D scenery. So what about setting the different visual effects in the application?
Sure, we can make use of the ability to generate in the game engine to enrich the visual effects in our city model. So first, by clicking the ArcGIS Map SDK, you could select layers and then paste the link of the mesh model to add the layer. We can also easily add the model in the Unreal Engine, and no configuration is needed for this action. So every time when the mesh model is updated from the Lens Department, and the imported model will be updated automatically without any further action. So other layers and objects could be also added to this game engine, depending on their own categories. So after import the city model, we can also adjust the lighting and atmospheric effects of the city model in the game engine. And there's different blueprints for you to choose to demonstrate the effect. So here we'll use the sun sky effect to demonstrate the sunrise and sunset in different days and different time. And we can also use the volumetric cloud functions to change the cloud effect by adjusting the altitude of the cloud height. And here we want to simulate the cloudiness effect of city, or is it a sunny day in the city also?
Traditionally, routing is done in the 2D map, like this, and with using the Hong Kong mesh model in the game engine, a more realistic experience can be generated for users. The game is set to be in Telford Plaza, and the player character can explore the city freely or follow the pre-planned routes that integrate into the game engine. The traffic condition can also be simulated in this game, which the player character needs to pay attention to the traffic condition and decide how to walk through the city. A checkpoint is set to the route to trigger some special events or actions for the player character. The character can then continue to explore the city with a transition from outdoor environment to indoor environment. And later, when the character reaches the second checkpoint, he can observe the indoor environment and take a look to the closer environment, such as the shops and restaurants in the surrounding. And then the character can move along the route, climb up the stairs, and reach the podium. Then, he can perform different actions set in the game, such as jumping, and explore Hong Kong with a new angle.
As you can see that, by integrating with the Lens Department mesh model and ArcGIS Map SDK, as a big step forward to create a metaverse in Hong Kong, and we're flying over the skies. And we can also use this case in a cave system, which is also empowered by the ArcGIS Map SDK, that we can put our models and our project on the screen of the cave. So today, we have a cave showcase outside this Scramble room. So please take your time during the lunchtime and coffee break to try on the cave. And here is the end of our demonstration. Thank you.